So
It's always
my
lovely
name
to
is
have
Buck Woody. I'm an applied data scientist here at Microsoft. What does that mean? That means I take the data science stuff, the machine learning and big data and all that, and advanced analytics, and I have to put it to use. I can't just talk about all these cool formulas and stuff. We actually go out and use them on customer projects. So what we're going to be talking about today, and you can cut over to the screen if you want to there, Simon, is the SQL Server big data clusters. And we'll just stay in this view for right now. I'm sort of watching the chat, the comments here. And then if there's more, thank you, Chashim. Appreciate that. And we'll walk that. I teach college and I do other things. So I'm used to watching the comments and stuff, and I'll address those as I can. Okay, so we're going to be talking about secure analytics at scale. So what we mean by that is companies want a place where they can keep large amounts of structured and unstructured data. And sometimes they want it in the cloud, and sometimes they want it on premises, and sometimes they want both. And sometimes they want it in a cloud that Microsoft doesn't run. Can we do that? Yes. So I'm a very simple man. I'm slow at things. It takes me a while to learn stuff. So one of my strengths is taking something complicated and explaining it simply. And the reason why that's a strength of mine is because I'm a simple person to begin with. So I have to explain it simply because that's the way I understand it. So we will do that. So feel free to pop your questions in there. We'll go through. We'll keep a watch on time. And I'll make sure, thank you, Ali, we'll make sure that we show some examples too. All this stuff, by the way, I'm gonna give you a resource to get all this information. So don't panic, just watch, just enjoy yourself, ask questions, whatever you'd like to do. Grab yourself a beverage, get ready for that tasty meal you're about to have at your break there. Okay, so let's talk a little bit about big data. What in the world does big data mean? All right. When I was younger, big data for me was a megabyte. That was literally big data for me. A megabyte was huge. Nobody had that. Thousands of dollars to get a megabyte drive and so on. Obviously, that's not big data now. And in fact, there is no sort of number for big data. Big data to me, when I describe it to people, the way I put it is big data is any data that you can't compute in the time that you have with the technology that you have. So let's assume you've got a Commodore 64, a megabyte is big data. If you've got a huge cluster, maybe a terabyte's not big data. It's not a size, it's what you want to do with it and how you want to do it. And of course, we think about where does this data sort of come from, right? Well, it's pretty easy to think about how this happens. We have a place to put it, and we've been putting it there longer. That's the simple explanation, right? You got that drawer in your house. You've seen this, right? It's right next to the refrigerator. When you first moved into your apartment or your house, that drawer was empty. And it's the one right next to the fridge, to the right or the left. And you started putting things in it. And you've been there a while in your house or your apartment, and now you can't even open that drawer. You don't know what's in there. That's big data. You've been in that house longer and you've been shoving things in that drawer because it was easy, and that's big data. Now, because of this, we need to do something with it. And you think about large retailers, some of the big box stores and so on. They've been collecting a lot of data. Every time you put your credit card in, every time you buy something, somebody's tracking that data that you're putting in there. So the next question becomes, if we've got big data, what do we do with it? So I've got a bunch of data. So what? How do I leverage this? Well, I've broken this down by sector, by like industry sector here. And keep in mind, these have changed over time. But this is, I think it's about 9 months ago, I did this research. The number one user of big data at the moment is retail. Second was finance, then healthcare and so on. This may have changed slightly a bit, but the number one use case used to be in-store analytics, and now it is demand prediction. So every time you go to get something and you go to buy it, they need to predict when they need to make, ship, and stock the next one. Robbie says, my understanding nodes need 24 disks and 64 gigs of RAM. I think somewhere in that realm. Do we need these kind of beefy settings for just a POC or learning BDC? No, I'll show you a place where you can put it in one VM. It's what I do. But we'll talk about that. By the way, we'll get to the architecture. We'll talk about that a bit, but it's big data. All right, so it's big data. That's how that works. You need a big system to process big data, but we have a learning environment for you much smaller. In fact, I'm running one right now on my system just underneath my desk here. I'm not even hitting something outside. But at any rate, we've got these use cases. These use cases are usually predictive or even prescriptive analytics, and those require a lot of data. Now, whenever you're doing data algorithms, you need to process this data because you show it good examples and bad examples, and the algorithm develops a bias towards one or the other and can then do predictions. So you need a lot of it to do this stuff, hence the reason for big data. So here's some of the use cases I think you can see this. One that's kind of interesting in finance, it used to be fraud detection. They were trying to detect fraud. Now they're trying to prevent cyber attacks. So it's kind of interesting that one flipped, and then you can see the rest of these blockchain computation and customer retention and so on. Okay, so that's the use case. So let's stop here. We've got big data. We got sources of big data all over the place. And then we have a reason to do big data. You're welcome, Robbie. So we got a reason to use big data. So far, big data, a reason to use it. What do we do? Well, when you have a lot of data, you can't scale up anymore. You have to scale out. So I'm a simple man. So I built a little cartoon for you. I'm not a good cartoonist either, but I did the best I could with my incredible PowerPoint skills here. All right. You've probably been to the grocery store, right? You went to a store and bought something, right? And so some people get in line. And then you get in line after all these other people, right? And here's the deal. There's a register here, yeah, that's got a computation on it. And that computation is really, really easy. It is take this item, record the price, and add it to the price of the next item that comes, n plus 1. That's it. That's it. Just take the n that you had, add the next item, and then do that again and again until end of list, until EOL. Very simple algorithm, right? And so the register is punching that in there, and you're standing there. You've got like 2 items, and the person in front of you has like 50, and they're doing everything with change, loose change, and you're like, oh my gosh, what's happening here? This is what's happening inside your computer. There are only 4 things in a computer: CPU, memory, disk, and network. Those 4 things are busy doing the computation. So if we think about this, what happens? Can we get somebody to come to register 3 or register 3? So yeah, hi Joshua, come to register 3. So register 3 opens up. Once register 3 opens up, you take your cart and you push it to the other line. And here's what's interesting. Stay with me here. Both of these registers have exactly the same algorithm, don't they? They both do things the same way. They use the same computation. But each of these grocery carts has different items in them, right? You've got your toilet paper and your bananas and your soft drinks, and somebody else has something else, right? So that's data. So the data is different, and it has moved over the same algorithm, but someplace else. They have distributed the processing. That's what's happening here. Now, at the end of the day, you got to put all this back together because the manager in the back, she wants to know the complete price of all the registers. So that's easy. Now, register A and register B just send their totals off, and that is calculated. And there you go. That's distributed processing. Okay, so all of you who are listening and paying attention and not checking your email or surfing the web, you are now allowed to put on your resume that you are a Hadoop expert. So you are now a Hadoop expert. Put that down on your resume, and I'll explain why you can do that. This right here, these grocery carts that you see on the screen here, that is HDFS, the Hadoop Distributed File System. The data has been spread out, and this particular piece in green here knows where that is. The map reduce is the mapping of the same algorithm across the data, and the reduce is this part right here. And the yarn, this is the person who said, hey, Bob, come to line 3. Bob, open up a register on line 3. That's yarn. Okay, number 3, you can take your break. That's exactly how this works. So if anybody asks you if you're a Hadoop expert, you say yes. I attended a class by Buck Woody, and I'm a Hadoop expert. All right, but this is slow. This is batch oriented, yeah? At the end of the day, we're waiting to calculate all this stuff. We want something much faster. So my good friends at Berkeley, California, invented something called Spark. Now, Spark still uses HDFS, and it still uses lots of computers. They call them Node. Is if you want to make more money in computing, you take something that already exists and you name it something else that sounds cooler, and then you can charge more for that. So we have these nodes, which are just computers. We have the distributed storage. But what Spark does is it reads this stuff into memory and does some networking tricks, and it's much, much faster. And it calls these things resilient distributed data sets or data frames. So it brings them up in, it just sits there. Then you lay a library over the top of them. And these libraries are quite interesting. They simply convert that RDD into something else. So for instance, if I want to use Spark SQL, which we'll do in just a moment, if we've got time, I think we'll have time to do that. I turn it into a data set. That's what SQL knows how to work with, or a data frame. Is how that knows to work with it. If I want to work with it in R or something else, I turn it into a data object. Josie says, not even after my software engineering MBA, I felt so comfortable to say that. Nicely done. You're an expert. No, you put that down, Josie. You put that down. Buck Woody said you're a Hadoop expert. All right. So it just lays libraries over the top of this. All right. Let's stop for a minute and let's talk about where we are, because I'm a simple man. We have large sets of data. We've got something to do with that data, and we now have a way over here to process that data. And now we have a way to process that data fast. Now we have a problem because of these nodes. See that? The registers, there are only so many. And we need to figure out a way. Do we buy computers and do we stand them up in racks? And then when we're done with them, do we call the computer company and say, all done, don't need it today. You can pick them up, take them home. Then you say, I need 30 more in 5 minutes. You can't do that, right? So what we did with our next part of the problem is we need to virtualize our computer. Now, going back to the mainframe days when I was around, we didn't actually have computers when I was little. We just had, we just yelled ones and zeros at each other across the room. But when they invented mainframes, this was the way things were done to begin with. And here's what this does. We have a physical computer, and the physical computer has the big four: CPU, networking, disk, and memory. Okay, it's running an operating system, some sort of operating system, a quality one like Microsoft Windows or something. And then on top of that, we have this technology called a hypervisor, and it does two things. The first thing it grabs a little bit of the computer's CPU, disk, network, and memory. It grabs some of those away. And then it presents what's called a BIOS, a basic input-output system, which is the thing that happens when you turn your computer on and all that stuff is flashing across. That's your BIOS, that bootstraps the computer. And the second thing that does is it looks at the hard drive and says, is there an operating system laying around? And so that's the second thing a hypervisor does, is it fakes a hard drive. It calls this a virtual hard disk. The combination of this fake CPU, disk, network, and memory, and the combination of this fake hard drive allows you now to install another operating system, even one that's not on the main computer, and it carves up the CPU, disk, networking, and memory. You have another computer. It's called a virtual computer. We used to call them virtual PCs. Now they call them VMs for virtual machines. All right. So now I can run whatever I want to in there, and it's very isolated. Remember our Spark thing? Now I can have lots and lots and lots of nodes running stuff. And I can have Python, some binaries, maybe some code, whatever, and they're all independent. Here is the problem. The problem I have with this is I don't need all the stuff that an operating system brings. I don't need a mouse or a keyboard or video or as much of the protection that it makes. Now I got to patch all these operating systems. Now I've got to secure all these operating systems. Now I've got to care and feed all of these things. They're like puppies. You get a puppy and it comes home. Who takes care of it? You do, not the kids. You're the one that takes care of it. So now you have tons of these things laying around, and they're not light. Just the operating itself needs a ton of memory and CPU and disk and network. And now you run all this stuff. So this is no bueno. We don't like this very much. Not only that, it's the same stuff and it's just ring fenced a little bit. So what do? We move on to the next way to virtualize, something called containers. Now, if you know containers already, great, good for you. If not, pay close attention. And after this, you will be able to add to your resume not only Hadoop, but also containers. This is the best spent hour you're ever going to have. All right. So once again, we have our physical computer, yeah? We got our operating system. And for reasons which are not important right now, this is usually Linux. What? A Microsoft guy saying that we're going to run Linux? Yes. And there's a reason for this. And it's not important right now. Just take my word for it. All right. So we got this operating system. We got the big four, CPU, disk, network, and memory. We're not going to reshare them. Why do that? I already have those. Why carve them up? So I'm not gonna. And I don't need another hard drive. I have a hard drive. So I don't need to do that either. So what I'm going to do is I'm just going to create something called a container runtime. You might have seen some of these. There's a lot of them out there. The main one is called Docker. You may have heard of this thing. Docker is something that we'll use. So after we get the container runtime, what does it do? All right. It takes a thing called a manifest, which is a text file. That's all it is, just text file. We used to have text files in my day. And then we went to INI files for a while. And then the whole world was written in XML. And now the whole world is written in JSON. So apparently we just keep renaming text files into something else. So it takes a JSON, JavaScript object notation, which has nothing to do with Java and nothing to do with JavaScript. But whatever, I digress. It actually puts all this stuff, and I don't think that's actually the acronym. But anyway, whatever it is, JSON. And it actually has a list of what you want. It's a lot like SQL, select star from table. You don't know where a table is. You don't know where the hard drive is. You don't care. Select from the table. In this case, I say, I want some stuff running. That's all you're going to say. You say, I want Python running, and I want some code, and I want this, and I want that. And you lay down that file. So the container runtime can then it can ingest that file and make a binary image of what you said you wanted. In other words, it says Python, huh? Let me go check. And it grabs a Python and it puts that there. And it says, what else you want? Some code? I'll go grab that. And it puts that there. And it says, what else you want? Oh, the database server? Let me go grab that and put that there. Now you have a binary image. When you turn that on, you have something called a container. And that's how that works. Now, a lot of people will use the word container for all three of those artifacts, but they are different. Now, as I said, you might have Python, binaries, and code. And that's all you have. And this very special little ring fence around this keeps this completely isolated. So yeah, it's running Python and your binaries and code, but nothing else knows about it. It looks kind of like a virtual computer, but it's not a whole virtual computer. So it's really small. And you can do it over and over and over. Now, here's what's cool about it. Let's say this container that I'm pointing at here on the left has Python 3.5, let's say, that you're running an app with. But you've got another app you want to run, so you're going to run Python 3.7 over here on the right in this container. You can do that, and it will pull down the image and build it and so on. Now, let's say the middle container also uses Python 3.5. Containers are smart enough, and it uses the Linux operating system well enough to where it will actually share that. It's a layering effect. So it doesn't actually reload it again into memory. Saves a lot of space because it's binarily okay. Now, in this case, the binaries, code, and code are different between container A and B, but the Python is not. Everybody got that? Okay, good. All right, looks like we're tracking here. Okay. All right, this is the way containers work. You may now put that down on your resume. Now, I told you earlier, if something's easy to do, then we do a lot of it. That's why there's so many people in the world. And I'll let you think about that on your own time, but that's the way that works. So now we've got sprawl. Let's stop a minute. Go back a little bit. Here's what we got. We got a lot of data. We got something we should be doing with the data. We've got a way to process a lot of data that's spread out. And we've got a way to do that at speed. And now we've got a way to make that pretty lightweight. But we've got a lot of them. Maybe like 10, maybe like 100, maybe like 20,000 of these things running around. That's just chaos, right? So we don't want that. So we invented yet another technology. And this is for the orchestration of all those containers. Stick with me here. Yes, Ravi, your resume's looking good. You're going to get to put one more thing on it. I know, get ready, right? All this learning, and we've only been at this, 30 minutes? It's amazing. All right, so here we go. This thing, you've probably heard, is called Kubernetes. And guess what it's made up of? Guess. That's right, just JSON files. Yet again, JSON files. What's the deal with the JSON files and developers? So you write out, I'd like these containers, which have JSON files of their own. Keep them together and keep them running. I want 3 or 4 of these things going all the time, and put it in a nice big network, and put the storage somewhere else, and handle security and handle all the network, and just do that for me. And I want to describe that in a file, and you run it. And that's Kubernetes. And here's the way that works. We've got our nodes, right? We remember this. This is our physical computers, because at some point it's physical computers, right? At some point there's this. And we've got storage. Obviously, we need to have disk drives somewhere. And they're sort of, they're separated from all this. They're not on those computers. They could be, but that's not best practice. We install this Kubernetes thing. It's just an API. And it gets installed on every one of the nodes. And it forms this web across all of these. Then you talk to that Kubernetes web, if you will, and it uses something called a pod, P-O-D, because remember, we have to keep changing the names to things to make more money. So we've called this a pod. What's in a pod? This is how we talk. We write it in the JSON file. Hey guys, I need to be in here. And we click right here, and we put containers in it, 1 or more, or like a lot more if you want. And you can group them however you want to do. But they stay together in a pod, even if it's just one. And you can stand up as many pods as you want. And you say to me, Buck, how do I know where to put these? I mean, how do you know that that's on node 1 or node 2 or no? You don't. That's the point. You tell Kubernetes, here's your servers, figure it out. This is amazing. Just figure it out. These can move around. I don't care where you put them. I don't even want to know. Doesn't matter. So it spreads out and makes this virtual group of computers with its own network address. So you hit the Kubernetes cluster this way, and then it goes inside and has its own network to talk to everything else. Yes, keep changing the names. Now, wait a minute. We got one problem here, though. If things can just move around, what happens to the storage? There's got to be some. They fix this. What they have is they have something called a claim. And the way the claim works is just a number. It's just a string, and it connects to something called a volume. You could think of it like a hard drive or a LUN or a space or a C drive, whatever you want to call it. It's just a pointer, which becomes kind of interesting. It's kind of like a little software wire, if you want to think of it like that. And here's what's cool. Let's assume our pod, the 1, 2, 3, 4, 5, our 5th pod there has a bad day. Something breaks and it goes away. And then it wakes back up. It will automatically, because it woke back up because Kubernetes told it to wake back up, it will pop out and say, that's my volume. Remount it and keep going. Wow, we have big data. We got a reason for big data. We got a way to process big data. We got a way to scale big data. And now we got a way to control the scale. Buck Woody wants to tell you how we use all this at Microsoft. Here's what we do. Ta-da, SQL Server Big Data Clusters. Notice the nodes are gone. Nodes are gone, right? I took them out because they're not important anymore. I don't care. Doesn't matter. I told it you run on these 5 computers. Go run on the 5 computers. Not my problem. You figure it out. So now I'm only going to work with Kubernetes, my pods, the containers in them, and my volumes. That's it. That's all I'm going to work with. So that's all I care about now. I type all that up and off you go. Here we go. First thing we know is that our administrator, she can use the commands to talk to just regular old Kubernetes. Let's stop here for a minute, because I said Kubernetes runs on Linux or whatever. Kubernetes runs lots of places. Like you can run it as a service. Amazon has one, Microsoft has one, Google has one. You can stand up your own, all that, right? It does all this for you. So we don't care where it's running. We don't care where it's running. We don't care where it's running. You could be running this on Amazon or in your office or in our office. Doesn't matter. You pick where you go. All right, here we go. The first thing that we lay down when she begins to install SQL Server big data clusters is something we call a control service. Now, I'm illustrating these as pods and nodes, the blue and the gray there, but they can be, you describe where you want these, how big and how many and so on. I'm just going to do this just to keep us a little isolated. So this picture, when it's done, won't necessarily be accurate, but it could be, depending on what you want. All right, here we go. So we got our control service. It wakes up, and the first thing it needs to do is create a little database for itself called a config store. So it's got a little pod and a node, and inside the little pod and a container. Inside the container is a little database that's keeping track of everything. No harm, no foul. Here we go. Next part, we need a way to know if all this stuff is working and how well it's working. So we need logs. And we need a performance tuner of some sort, a performance view of some sort. And there are two open source ones that are really good. Grafana is a great tool that lets you look at performance counters. It will collect them from anything. You can have SQL Server and Linux and Python and whatever you want. And it'll go reach out, it'll monitor them, and then it'll pull it in. And I'll show you how it does that in a minute. All right. Once they're stood up, the control service has a little proxy that it makes. And now the administrator, she can look at the proxy, and the proxy can look at Grafana and Kibana. Kibana is a logging thing, and she can look at all that. And it's all on a web page. It's all inside a web page. So she's just hitting this thing with just webs, right? All right. Now, once those guys are healthy, we need to start installing SQL Server. So we do. We install SQL Server. We call this the master instance. Now, you hit that the way you hit any SQL Server. It's got a TCP/IP address. It's got a port. And you talk to it in your apps like it's SQL Server. You can use Management Studio, Azure Data Studio. You can use whatever you want. It'll work. All right. Once that's running, you may want to talk to data that is not inside your network. We do something with this called Polybase. And Polybase lets you mount other kinds of data like it's a table in SQL Server. You don't move it. You don't copy it. You simply, it's like a view. You can just point to it. That's called Polybase. And I mean, we can talk to Teradata, Oracle, SQL Server, of course, DB2, HDFS, another HDFS, and so on. Question, Thomas, can an existing data lake be made part of a big data cluster so data doesn't have to move? Absolutely. Not only that, you can use big data cluster as your data lake and the data doesn't have to move. So you could certainly point, or you do both, to where you have data you need in here and you have data you need out there. If I've got time, I'll show you guys an example. Pretty cool stuff. All right. We have another thing. What if you want to keep a bunch of relational data, like terabytes or petabytes of relational data, like BI type stuff? So you want not only that external data that is non-ordered, but you want to keep ordered, regular RDBMS data. We have something called a data pool. And inside that data pool, you talk to, again, look at the line from the application over there. You only talk to SQL Server. It handles all this other stuff for you. I'll show you. It's a thing of beauty. All right. Next, we talked about that whole Spark thing. So we've got, a couple pods in there and some containers in that pod, and we give you Spark and more SQL Server that talks directly to HDFS. So once again, you talk to SQL Server and it will talk to Spark for you. You don't have to learn MapReduce. You don't got to go learn Python. None of that. We'll do all that for you. So that's the way this looks. But wait, there's more. What if you create a machine learning model and you want to score it or something? You want to get a response back, but you want to stay in this security boundary. We can do that with something we call an application pool. So you can deploy your models with Python or whatever else you want to serve. In here, there's a little proxy. So now your users can hit that. By the way, your users can also use the Spark directly if they want, but they don't have to. All right, good. All right, that's as complicated as that one gets, I think. Yeah. I'm going to bail out a slide world here for a minute. And I'm going to show you guys. Let's go take a look at this stuff really working. Let's go do that. Hopefully you can see that okay. This is Azure Data Studio. It's an open source tool. It runs on Linux and Windows and Mac and whatever. I'm hitting a regular server here. So here we go. I've got a big data cluster over here, and you can see I've got databases and all that. But you can also see I've got an HDFS location, and that goes back. Let me pop back over to Slide World a minute. So that is right here. See this right here? That right there is this right here, HDFS. There we go. It's got directories in it and all that. This is huge. Now, by the way, this is that single node I was telling you about. You can run one of these very small, but Obviously, this is meant to be really, really big. All right, here we go. So first of all, when I hit this, it's just SQL Server. So now here's what's kind of interesting. You're looking at a notebook here. If you've never seen a Jupyter notebook, Jupyter Notebook's nothing but a fancy web page. It can run code and it can have text. That's it. Don't get excited. It's not that big a deal. Here's some text, right? And here's some code, right? And the code is dependent on the kernel. Whatever that kernel is, that's what you run in here. All right, so I'm running SQL in here. No, you won't normally see that in Jupyter Notebooks. We wrote that, so we actually contributed back to that. All right, so here we do. You probably know what this is. Select at version, SP configure, database name, where are you at, all that kind of stuff. I run the cell, and it does the work. So let's see what it came back with. This is SQL Server. I'm spreading this out. I have my screen really big so you guys can see it. It's Developer Edition. Come on, man. It's Developer Edition 64-bit, on Linux. So let me be clear here. Hold on. Microsoft SQL Server running on Linux. Interesting. Yeah, we wrote so that you could have SQL running on Linux, and it does, and it works amazing. And now it can run inside a container because that runs on Linux. And that container can run on a pod, and the pod can run on a Kubernetes cluster, and the cluster can run on a node. Ta-da! Now we're part of that big data world. We can do this. We can do this because we can run in Linux. And so we wrote to do that. All right, here we go. All right, so I just did some stuff, and really the only thing you're going to see different between this, you might see, it's kind of funny. Let me put this slide down so I can see your questions if you have one. All right, it's kind of funny. Look at the path for master database files and stuff. Isn't that wild? var opt, right? That's all Linux with the forward slashes and all that. They do that way. And I can select data. I can come down here and I can just select data. And by the way, I got the worldwide importers backup file from my Windows SQL Server 2016 Express Edition on my laptop, and I backed it up and I put it in SQL 2019 in Linux, the backup file, and I said, restore that. And it restored it and it upgraded it. Hold on a minute. It actually upgraded it automatically from the old version to the new one. So that's kind of cool. And I can back up from here and go restore it in Windows. No problem. Works great. All right. Now, once I've ingested some data, it's just SQL. It's just SQL. So now I can just start questioning it and this wide world importers and so on. So here we go. All right. Now let's go to the next step. That's pretty cool. But let me go to the next step here. What if we want to talk to data that isn't in SQL Server? In fact, what I'd like to do is I'd like to go down to my my partner customers here, and I want to get that file, this comma separated value file. Keep in mind, there may be millions of them. Remember the shopping carts? There may be millions of shopping carts in here, but they all have the same structure, right? And I want to talk to that, but I want to talk to it with SQL, with SQL, like it's a table. Now, you normally have to write all kind of code to make that true. In this case, you don't have to do that. All right, here's what I do. First of all, I tell it, I need a file format for CSVs. I called it CSV file. I'm very clever that way. And I told it, guys, this is Linux, right? So I told it this is Linux. Now, this looks just like what you would do with BCP, only we're not going to import the data. We're just going to point to it. Interesting. So first, I just made a comma separated value file. Now I said, create an external data source. So I need kind of a connection over to that thing. And this right here, by the way, is a HDFS endpoint. That's just the HDFS server, like this thing. That's just this whole thing right here, this gray box right there, all right? So that's what that is. All right, once I've done that, it says, okay, by the way, I don't have any security here because it's inside my data, my big data cluster. This could have been over on Amazon, and I had to provide names and passwords or certificates or whatever, and there's a way to do that. This could have been Oracle. This could have been DB2. This could have been Teradata. This could have been SQL Server. That's living somewhere else. Now, I get a table in here. I literally get a table in here called, let me see if I can find it real quick. I'm not going to spin on this. Let's see if I can find it. I don't remember what schema I put under and all that. So I basically created an external table now, and this is just the definition. This is just the definition of, where is that? Partner customer. It is literally the definition. Let me show you this file real quick. View, preview. Let me show you this. So it's got 3 columns, boom, boom, and boom. That's what that's got. No, I don't want to save it. And here we go. Customer source, customer name, email address. That's what's in that text file. And here's the trick. Here's where it is. Here's the directory, not the name of the file. Don't care about what the name of the file is. That's HDFS's problem. So it's going to walk across all these files. I am querying a directory. I am not moving the data. All right. So I do that. And now I can select top 10 and I can come out of that. I've aliased it with HDFS, and here it comes. And those weird little characters, they're in the file, right? So I am doing a select statement against HDFS data. No MapReduce, none of that. Isn't that cool? And by the way, I can now join them. I want to know the company over there. They sent me a list of names and addresses and all that. And I want to pair that up with data I have inside my SQL server. And so I just do a join. I just go get the HDFS person right there, and I go grab the local file name right out of my customer source, and I join them up, and there we go. These people exist in both databases. Ta-da! I just joined data from HDFS and SQL, and I just did it with a pointer, and I didn't move the data. All right, now what if I want to store a bunch of data from HDFS, but in a relational table? I can do that too. I do it exactly the same way, except this time I make a data pool instead of the HDFS. I also use the HDFS to go find the web click streams. I think that's in the web logs. Here we are, web click streams. I go get that, and I take it out of here, and I am moving it this time, and I save it with a insert into. This doesn't scare you, does it? It's right here. Insert into, just a regular old insert into. Now I did move the data because I wanted it to be relational, and I could have done all kind of SQL-y things. In fact, this is kind of ETL with a query. It's kind of weird. I could have had an Oracle table and an HDFS and a bucket over in Amazon. I could have queried them all, done some joins, uppercase this, lowercase that, and then do an insert into after that. Boom, Bob's your uncle. I've got all that data ETL'd right into my system. That's all I had to do. Amazing stuff. Now, what if I want to use that cool Spark stuff? So now what I'm going to do is I'm going to change my kernel to PySpark, which is the Python that Spark uses. I'm going to attach it to that same computer, to that same cluster, same node. Can SQL Server on Linux use permissions defined with Active Directory? It can. It can. I can't show you that right now. It's complicated. It's complicated. Linux is a mess, but yes, we can do that. Okay, Spark for ETL. I've got a lot of data, tons of it, millions and millions and millions of rows. And I want to do the ETL not in SQL or anything else. I want to do it in Spark because, hey, it's what Spark does. So all I do is start up a Spark thing. All I do is a Spark call, which looks like this. There's the file format. Here's the blah. Save it as a table. That's what it does. Save it as a table. Then it writes down a ton of stuff. And now I can say, run some Spark over that table I just made. And this is like limit 10, top 10. That's what that is, right? And then show it to me. Look at that. So now I can use my SQL-y magic, my SQL foo. I can use that in here on Spark. Isn't that awesome? And so now I've got a file there. And by the way, I could take that file and then look at it with SQL. I could do both. My data science, she's working away. My DBA, he's working away. They can be working on the same data at the same time. Just amazing stuff. All right, here we go. Machine learning. We're coming into the home stretch. We want to put all this together. Long story short, what I did was I made a Python Spark model. I went out and got a ton of data. I did all kind of data science-y things to do everything. I looked at the data. I did data ingestion. I did feature engineering. Yeah, whatever. All that stuff is really cool. Don't tell anybody that I told you this because this is part of our secret decoder ring that we use as data scientists. This is all I really do. I added a comment here to make it look like I was doing more because it was just 3 lines and that didn't look right. So I added a line to make it look like I was doing something important. And all I'm doing here is I'm using one of the most common models you can use, which basically fits a line. That's what it does. And it says, well, it was this way yesterday. So, it was cold yesterday, but it's going to be cold today. That's all it did. Once it's done, I can make a prediction. Now, here's what's cool. I can actually save all that out. I can do predictions. This one's doing predictive maintenance. It's telling me when a battery on a component is going to fail. Literally when. I predict this is about to go bad in like 3 minutes, you better go fix it, right? And it sends me a thing. Here's what's cool. This is for a refrigeration unit on a truck. So what I can do is save that model once I've trained it with all that big data. Now it's tiny because I don't have the data anymore. I've just got the model. It's just tiny. And I pop that out and you can run it on something called SQL Edge. And SQL Edge is SQL Server running on a tiny little like Python box, little tiny guy, a chip, if you will. Now I can embed that in the truck. The truck's monitoring the system, a refrigeration system, all the time, 24/7. And it says, hey, dude, tomorrow at 3 o'clock, your battery's going to die. I've already ordered it for you. It's waiting for you at the next truck stop, and they've been notified to set up an appointment to put it in for you. And so the truck driver pulls over, gets the battery, keeps going. No more replacing batteries every month when you don't need to. No more spoiled goods so that the ice cream's not damaged when you do. And Joe asked the best question, which is, do you have a website or a blog with all this crap on it? I mean, my gosh, it's a lot to keep in mind. And it is. So I'm going to pop through because there's a bunch more stuff here, folks. This is where I show you kind of how the guts all work and all that. You don't care. It's not important. This talks about the Active Directory stuff that you asked about, and it shows how all that works. And I show an example of how Financial Tech does their work. They do a fraud detection thing. I've got all this somewhere else, so I'm not going to spend time on it. I'm going to get to the answer to your question. Ta-da! Joe, ask and ye shall receive. If you want to find all the documentation, which has everything I've gone over, just go to akademis/BDC. But if you want some in-depth training, hands-on, that goes step by step and does everything I did and reduplicates all of it. And you learn along the way with free training on Kubernetes, free training on containers, free training on machine learning and HDFS, everything you can imagine. Go to aka.ms/SQL workshops. And you'll find, this is a neat little secret, not just big data cluster stuff there, but all the stuff from Bob Ward and Anna Hoffman. You'll find there as well as yours truly. And then if you just want the code examples, various code examples, we've got those there at aka.ms/BDC samples. Well, Simon, I'm out of breath, man. We're on time and on budget. I mean, it's time for me to eat lunch. I haven't had lunch, so I got to go get a sandwich or something. But this is the resources there that you've got, folks. Simon, if you want to bring that back, okay, everybody take one of those screenshots. Hold on a minute before you take a screenshot. Simon, make a funny face.